In this video, we're going to start the KutaSoftware free worksheet, Graphing Absolute Value Functions, under the Infinite Algebra 1 section. I'm going to split this worksheet up into 3 separate videos, doing numbers 1 through 4, 5 through 8, and then finally in the third video, 9 through 12. So let's go ahead and get started. Our directions are to graph each equation. In number 1, we have y equals the absolute value of x minus 2 minus 4. Now, graphing absolute value functions is actually easier than you think. We're going to use the t-table to graph each of these functions. Absolute value functions have a turning point that's known as the vertex, and it's either a minimum or a maximum more specifically. So let's ignore this equation for a second and think about y equals the absolute value of x. So when y equals the absolute value of x, if you have negative 3, the absolute value of negative 3 is equal to a positive 3, so negative 3 in the x direction, positive 3 in the y direction. Same with negative 2, it's going to be a positive 2, so the absolute value of negative 2 is positive 2. Continuing on to negative 1, the absolute value of negative 1 is a positive 1, then the absolute value of 0 is 0, and then we'll get into positive 1, so the absolute value of positive 1 is a positive 1, and so on. We know that absolute value of 2 will be 2, absolute value of 3 will be positive 3. So you can see the turning point occurs when that absolute value was equal to 0. So it's a straight line until the turning point, and then it's a straight line past the turning point. So we have a negative slope, and then immediately we have a positive slope, and all of that changes at that point 0, 0. So the turning point occurs when the absolute value is equal to 0. That's true for all of the linear absolute value functions. So in order to graph this function, we're going to find the turning point, then we're going to find the coordinate for a number that's less than that turning point and a coordinate for a number that's greater than that turning point. So let's go ahead and start number 1, now that we have an understanding of how to graph the absolute value functions. So we know that turning point occurs when the absolute value is equal to 0. So we're going to look strictly at the absolute value function. So the absolute value of x minus 2, we have to solve for when that's equal to 0. So we're looking at when x minus 2 equals 0. So we're going to add 2 to both sides to get that x equals 2. So our turning point occurs when x is equal to 2. Now let's plug 2 in for x and solve for y. So we're going to have the absolute value of 2 minus 2, which we know is 0, minus 4. So the absolute value of 2 minus 2 is the absolute value of 0, minus 4, which we know that the absolute value of 0 is simply 0. So negative 4 is going to be equal to y. So when x is 2, y is negative 4. Now let's pick a point that's less than the value of 2. So it's going to be to the left of our turning point, or vertex. So let's choose 1. When x is 1, we're going to have the absolute value of 1 minus 2, and then minus 4. The absolute value of 1 minus 2 is the absolute value of negative 1, and then we're subtracting that 4. We know that the absolute value of negative 1 is a positive 1, and when we subtract 4, we get 1 minus 4, which is a negative 3. So when x equals 1, y is equivalent to negative 3. Now let's pick a number that's greater than 2, so it's going to be on the right side of the turning point. Let's just pick 3. We're plugging in 3 for x, so we're going to have the absolute value of 3 minus 2, which is the absolute value of 1, and then subtracting 4. The absolute value of 1 is simply 1, so we have 1 minus 4, and that's going to give us, again, a negative 3. So now we have the point 3, negative 3. So when x is 3, y is also negative 3. Now let's plot those. We have 1, negative 3, 2, negative 4, and 3, negative 3. And just like that, we'll be able to now draw our lines. starting at the turning point, drawing a positive slope, and then we'll draw the negative slope. And that's the answer to number 1. Also note that this absolute value function is symmetrical. So if we were to draw a line straight down through that vertex, our points or our lines are mirrored. That's why when we went one less than the turning point in the x direction and one greater than the turning point in the x direction, our y values are both -3. Let's go ahead and move on to number 2. Set up our xy t-table, and we're going to solve for that turning point. So that's when what's inside the absolute value is equal to 0. So x plus 1, when does that equal 0? We're going to subtract 1 from both sides to get that x equals -1. So when x is -1, whatever our y value is, that's going to be our vertex. So we'll write -1, and I like to put it in the middle of my t-table so I know that I need to do a point that's less than that -1 value and a point that's greater than that -1 value. So let's go ahead and plug in -1 for x. So when we plug in -1, we get that y equals the absolute value of -1 plus 1, which we know is y equals the absolute value of 0, which is 0. So when x is -1, y is 0. Now I'm going to do 1 unit less than the turning point in the x, so I'm going to choose -2, and 1 greater than the vertex x coordinate, 0. So now if you remember, we talked about the absolute value function being symmetric. Since -2 is 1 less than -1 and 0 is 1 greater than -1, those two should have the same y values. Let's check it out. So if we plug -2 in for x, we get that y is equal to the absolute value of -1. So y is going to be equal to +1. So when x is -2, y is a +1. Now let's plug in 0. When x is 0, we get that y is equal to the absolute value of 0 plus 1, which we know is the absolute value of 1, and the absolute value of 1 is equal to 1. So when x is 0, y is a +1. So you can see, like I said, since it's symmetric, -2 and 0, since they're both 1 unit away from the turning point's x coordinate, or x value, they have the same y values. Let's go ahead and graph it to get our answer. -2, +1, -1, 0, and 0, 1. It's a straight line to the turning point and then a straight line from the turning point. And I recommend using a straight edge like a ruler or another piece of paper when drawing your lines for linear functions. Let's move on to number 3. Again, we're going to have our t-table with x and y values. So now we're going to figure out our turning point. The turning point occurs when what's inside the absolute value quantity is equal to 0. So that occurs when x is 0. When x is 0, our y is a +1, since y equals 0 plus 1, which is simply 1. Now I'm going to choose a point that's less than the x value, so -1, and I'm going to do a point that's greater than the x value of 0, so a +1. When we plug in -1, we get that y equals the absolute value of -1 plus 1, so that's going to be y equals +1 plus 1, so y is equal to 2. So when x is -1, y is a +2. Now let's plug in a +1. If we plug in a +1 for x, we get the absolute value of 1 plus 1, which we know is 1 plus 1, which will give us 2. So when x is +1, y is a +2. Now we have 3 points, including our turning point, so let's go ahead and graph this. -1, 2, 0, 1, and 1, 2. And that's the answer to number 3. Moving on to number 4. Again, with the t-table, we're going to locate the turning point, which occurs when what's inside the absolute value equals 0. And because we just have x within the absolute value, we know the turning point occurs when x is 0. So plugging in 0 for x, we'll be left with y equals 0 plus 2, so y is equal to a positive 2. And then I'll do 1 point less than that 0 and 1 unit greater than that 0. So if I plug in a negative 1, I get positive 1 plus 2, since the absolute value of negative 1 is positive. So y is going to be equal to 3, since 1 plus 2 equals 3. X negative 1, y positive 3, and then plug in a positive 1. The absolute value of positive 1 is 1, so 1 plus 2 is also 3. Graphing those 3 points, we'll have negative 1, positive 3, 0, 2, and then 1, 3. As always, remember to like this video and subscribe to my channel. Each subscription and like is greatly appreciated. And if you have any questions, please feel free to comment below. In the next video, when we do numbers 5 through 8, I'll go more in depth with locating the turning point, and I'll show you a quick, simple trick to find the turning point, otherwise known as the vertex, without actually plugging in any values into the equation. So stay tuned for that and continue on. In this video, we're continuing on with the Graphing Absolute Value Functions worksheet on the KutaSoftware website, and I'll leave a link in the description below so you know how to access that. So picking up with number 5, we're going to plot the equation y equals the absolute value of x plus 2. We're going to start with the t-table, and we have to find the turning point. If you remember from the last video, the turning point occurs when what's inside the absolute value is equal to 0. So x plus 2 equals 0, subtracting 2 from both sides, that x is going to be equal to a negative 2. So when x is negative 2, this absolute value of x plus 2 is equal to 0. Let's plug in for x to solve for y. Negative 2 plus 2, we know that equals 0, and the absolute value of 0 is 0. So when x is negative 2, y is equal to 0. Now we're going to find the y value for an x that's less than negative 2 and a y value for an x that's greater than negative 2. If they're the same number of units or same number of steps away, let's say I choose negative 3, that's 1 less than negative 2, and negative 1, that's 1 greater than negative 2, the y values should be the same since the absolute value functions are symmetric. So let's go ahead and do the math. Plugging in negative 3, we get the absolute value of negative 3 plus 2, and that's going to be equal to the absolute value of negative 1, and the absolute value of negative 1 is a positive 1. Y is equivalent to 1 when x is negative 3. Now plugging in a negative 1, we get negative 1 plus 2, which leaves us with a positive 1, so the absolute value of positive 1 is 1. So y equals 1 when x is negative 1. So you can see that when x is negative 3, 1 step less than negative 2, or negative 1, 1 step greater than negative 2, the y values are the same. Let's go ahead and graph this. We have negative 3, positive 1, negative 2, 0, and negative 1, positive 1. So the absolute value function has two straight lines coming out of the vertex. One is a positive slope, and the other negative. And that's the answer to number 5. Moving on to number 6, I'm going to go over that trick, or that helpful hint that I mentioned in the last video, about finding the turning point without having to plug in any values. Let's go ahead and just write our t-table. Now we know the turning point occurs when what's inside the absolute value is equal to 0. So that's going to happen when x is negative 1. So it's going to be the opposite of whatever number it's added to or subtracted from. So if we had x plus 2, like we did in the last problem, we knew that was 0 when x was negative 2. If we had x minus 3, well, this is the same as x plus 3, so we know that that turning point occurs when x is negative 3. Negative 3 plus 3 is 0. So right away we know that that turning point occurs when x is equal to negative 1. And since the absolute value is 0 when we plug in that -1, we know that the y value is just going to be what's left over, which is that +3. So as opposed to plugging in -1 and doing the math out, you can see that we know that this is 0 at all the turning points, so whatever value is left outside the absolute value function is going to be equal to that y value. Now let's take one point that's less than that, so -2, and we'll do a point that's greater, 0. So when x is -2, we have the absolute value of -2 plus 1 plus 3. -2 plus 1 is -1. The absolute value of -1 plus 3 is what we have left. The absolute value of -1 is equal to a +1, so we have 1 plus 3, which is equivalent to 4. So y equals 4 when x is -2. And since it's symmetrical, we know that since we went 1 less than -1, when we go 1 greater than -1, they have the same value. So we know that 0, 4 is another point on this absolute value function. So now that we have the 3 points, including the turning point, let's go ahead and graph that. -2, 4, -1, 3, and then 0, 4. And that's the answer for number 6. So you can see that finding the turning point and then finding symmetric points makes graphing absolute value functions a lot easier than picking random points and then graphing. Because think about it this way, if you picked random points not knowing what the turning point was, and you started by picking -4, -3, and -2, you would get simply a straight line and not know that this function was turning. But we can recognize that since it's an absolute value function, it's going to have a vertex at some point. And it's easier to find that vertex at the start as opposed to plugging in number after number until we eventually find it. In number 7, we have y equal to the opposite of the absolute value of x minus 2 minus 2. So again, we're still going to locate that turning point. When this absolute value function is 0, which occurs when x is a +2, since 2 minus 2 is 0, that y value is going to be what's left on the outside, which is -2. So now that we have our turning point, we'll plug in one value less, and we'll plug in one value greater. So we know that these are equivalent, so now all we have to do is plug in a single x value. Let's go ahead and plug in the 3. So we have y equals the opposite of 3 minus 2 minus 2. That's going to be y equals the opposite of the absolute value of 3 minus 2, which is 1. The opposite of the absolute value of +1 minus 2. We're going to have y equal to the opposite of the absolute value of 1, which is a +1, so we have -1, and then minus 2. -1 minus 2 is going to give us -3. So when x is 3, y is -3. Same with when x is 1, y is also -3. And if you don't feel comfortable, still feel free to plug in that 1, or you can do it now and double check. 1 minus 2 gives us a -1. The absolute value of -1 is +1, but we're taking the opposite of that +1. So it's a -1 minus 2, which gives us, again, a -3. Graphing those, we have 1, -3, 2, -2, 3, -3. So we have a positive slope going into the vertex and a negative slope coming out of the vertex, which is flipped from the other ones because we're doing the opposite of the absolute value. If this was positive, then it would look something like this, as opposed to that. Let's move on to number 8, which is the last function we're going to graph in this video, and in the following video, we'll finish out with numbers 9 through 12. So doing our t-table, we're going to find the turning point. So that's when x is -1, and when x is -1, our y is a +4. I'm going to do 1 point less than -1, so that's going to be -2, and 1 point greater than -1 is 0. I'll go ahead and plug in 0 for x, so we will be left with y equals the opposite of the absolute value of a +1 plus 4, so y is equal to -1 plus 4, since the absolute value of 1 is 1, and we're taking the opposite of that, so it's a -1 plus 4, so y is going to be equivalent to a +3. And since they're both the same distance from that turning point, the values are the same. So -2, 3, and then 0, 3. Plotting those, and then connecting the lines. And that wraps up this video. Please remember to like and subscribe. Both are greatly appreciated. In this video, we're going to wrap up the KutaSoftware free worksheet, graphing absolute value functions. And I'll leave a link in the description below so you know how to get to that worksheet. The tips and tricks to remember: we're going to find the turning point first. Once we find that turning point, we're going to pick two x values that are the same distance from that turning point to use as x coordinates. And since they're the same distance from the turning point and the absolute value function is symmetric, we know that those will have the same y value, so we only need to actually plug in one x value to solve for both of them. So let's go ahead and get started. The turning point occurs when what's inside the absolute value is equal to 0. We know that by choosing the opposite number, we're going to get to 0. So the turning point occurs when x is equal to -4, since -4 plus 4 equals 0. Also note that if this absolute value is 0, we're only left with 2 outside of that, so that y value is going to be equal to a +2 when x is -4. So here we have our vertex, -4, 2. We're going to pick an x value that's 1 less than -4, so that's going to be -5, and an x value that's 1 greater than -4, so that's going to be -3. And like I said, since the absolute value function is symmetric, the y values will be the same. So let's just plug in -5. We have y equal to the opposite of -5 plus 4, the absolute value of that quantity, plus 2. We have y equal to the opposite of the absolute value of -5 plus 4 is going to be a -1, and then we're still adding that 2. So y is equal to the opposite of the absolute value of -1, so it's equal to the opposite of a +1, since the absolute value of -1 is +1, and then we're adding that 2. So y is going to be equal to -1 plus 2, which is a +1. So when x equals -5, y is +1, and same when x is -3, y is also +1. We're going to go ahead and graph those 3 points. So -5, 1, -4, 2, and -3, 1. Then we can connect them with two separate lines intersecting or meeting at the vertex. And that's the answer for number 9. In number 10, set up our x, y, t table. This is now 0 when x is a +1, since 1 minus 1 is 0. So the turning point or the vertex occurs when x is a +1 and y is also a +1. So I'm going to plug in 0 for x and solve to get y, and that y value is going to be the same for when x is a +2, since 0 is 1 less than 1 and 2 is 1 greater than 1, which is the x coordinate for our turning point. So plugging in 0, we get y equals the opposite of 0 minus 1 at the absolute value of that quantity plus 1. So y equals the opposite of the absolute value of 0 minus 1, which is the absolute value of -1, plus 1. So y is going to be equal to the opposite of the absolute value of -1 is a -1, since the absolute value of -1 is 1, and we're taking the opposite of that, that's -1, and then we still have to add 1. So y is going to be equal to -1 plus 1, which is 0. So when x is 0, y is 0, and when x is 2, y is also 0. Now that we have 3 points, let's go ahead and graph this absolute value function. We have the point 0, 0, we have the point 1, 1, and we have the point 2, 0. So we have 2 lines with opposite slopes meeting at the vertex. And that's the answer for number 10. And number 11, same thing. Set up our xy table. The turning point occurs when x is equal to a positive 2, since 2 minus 2 is 0. And what's left is that positive 4, so the y value is 4. We're going to pick 1 less than 2, so that's going to be positive 1, and we're going to pick 1 greater than 2. That's going to be a positive 3. So when x is 1 and when x is 3, the y values are going to be the same. Let's go ahead and plug in 3. We have y equals the opposite of the absolute value of 3 minus 2, and that quantity gets added with 4. So we have y equals the opposite of the absolute value of a positive 1 plus 4. The absolute value of 1 is 1, so we have negative 1 since it's the opposite. So negative 1 plus 4, so that y is going to be equal to 3. So when x is 1, y is 3, and when x is 3, y is also 3. Plotting those points, we have 1, 3, 2, 4, and 3, 3. Then we're just going to draw 2 lines intersecting or meeting at the vertex. And that's the answer for number 11. Lastly, we're going to move on to number 12. The turning point occurs when x is equal to 1, since 1 minus 1 is 0. So y will be -1. Now we've always been doing 1 less than 1 and 1 greater than 1, but I want to show you that it doesn't matter how many steps you are away from 1, as long as the distance from that vertex x coordinate is the same, the y's will be equivalent. So let's go 2 away from 1. Going 2 less than 1 will leave us with -1, going 2 greater than 1 will leave us with a positive 3. Now these y values are going to be the same, but I'm going to plug in both -1 and 3 so that you can see that. Plugging in a -1 for x, we get the opposite of the absolute value of -1 minus 1, minus 1. So we get the opposite of the absolute value of -1 minus 1 is going to be -2, and then minus 1. The absolute value of -2 is a positive 2, but we're taking the opposite of that. So that's -2 minus 1, which is equal to a -3. So when x is -1, y is -3. Now let's plug in a positive 3. We have the opposite of the absolute value of 3 minus 1, minus 1. The opposite of the absolute value of 2, minus 1, will give us the opposite of 2, which is -2, since the absolute value of 2 is a positive 2, and we're doing the opposite of that. So -2 minus 1 will give us -3. So when x is equal to 3, y is equal to -3. And you can see, indeed, that the y values are the same. Let's go ahead and plot these 3 points. So we have -1, -3, 1, -1, and then 3, -3. And then you just draw your 2 straight lines that connect into the vertex to get the function for this absolute value equation. And as always, any subscription or any like of a video is greatly appreciated. Also, please feel free to comment below if you have any requests for a worksheet or any questions about what we went over in this video.